Hello guys, my name is Lazaro, and today we're going to be doing a LeetCode problem. Now, if you're unaware, the reason we're doing these video solutions is because we currently have an event going on our Discord channel. Now, this is the event right here. It's called the LeetCode Winter Grind, and it's going to last 2 weeks, from the 13th to the 24th of December. And of course, we have video solutions. We're going to be sending out 6 problems a day, and this will be a new concept every other day. So, for example, right now we're going to be going over an array problem, and we're going to be going over arrays for 2 days, for the 13th and the 14th. After that, we will dive into a completely new topic. Now, if you guys want to join the Discord channel, it's down in the description, but as you can see, it's also right here. So you guys can easily join. I can show you how to navigate around. So this is Discord. Right here, we have three problems in advanced, and then 3 problems in beginner. I'll be doing one solution video from each set, one from beginner and then one from advanced. So as soon as you join, you might be in general. I highly recommend you head over to Dev Communities, this channel right here, and then click the LeetCode emoji to gain the interview training role. Once you have that role, you have access to this channel, and you also have access to the beginner and advanced problems channel. And of course, if you are able to solve these, we highly recommend that you post it in this thread called LeetCode Solutions. And as you can see, a couple of people have already started doing that. Anyways, let's get right into the problem. So this problem is called Final Prices with a special discount in a shop. Given the array prices, where prices of I is the price of the ith item in a shop. Okay, so far we know we're given an array, and we know what each element in the array represents. Cool. There's a special discount for items in the shop if you buy the ith item. Okay. Then you will receive a discount equivalent to prices of j, where j is the minimum index such that j is greater than I, and prices of j is less than or equal to prices of I. Otherwise, you will not receive discount at all. So what exactly this is telling us? Okay, so the price for the ith item, the item in front of of that location, so that's what this j greater than I means. The minimum index where the price of j is less than the current price of I will get a discount by just taking the difference. We can go more in depth into what this really means with a couple of examples down here. So now they want us to return an array where the ith element is the final price you will pay for the ith item of the shop considering the special discount. So we're going to be returning an array with the discount taken into account. Cool. So let's look at the first example. Our prices array contains the elements 8, 4, 6, 2, and 3. So the first item, or item 0, since we're 0 indexed, has a price of 8. The second one has a price of 4, then price of 6, 2, and 3. For the first item, it costs 8. But now to find that minimum j index, we will have to look forward and stop as soon as we find an item that's less than 8. So here our I is 0. If we look one forward, we have a j of 1, where prices of j is less than 8. So 4 is less than 8, therefore the discount is 8 minus 4, and we will pay $4. They kind of explain it pretty nicely right down here, in case you guys didn't get that. But we'll receive a discount equivalent to prices of 1, which is 4. So let's go a little bit more depth. They have a couple other examples that really don't have explanations. And let's also look at the constraints. So the length of prices is actually pretty short. It's only 500. But the price of an actual item can be pretty large at 1,000. But these constraints is nothing really to worry about. Even if we do an n squared solution, we should still be fine. But there is a better approach, as you guys will see. So let's write down that first problem. 8, whoops, 8, 4, 6, 2, and then 3. Now, something that I want you guys to notice is that every single item that we encounter in this prices array serves two purposes. Number one, it could be used as a discount for the previous items. Number two, we should hold it as we might apply a discount to it later on. Now, this holding factor might give it away, but what data structure we want to use to solve this problem is a stack. For example, let's have a stack right here. At 8, let's see if we can use it for any previous items we've seen. Well, since we haven't seen any previous items, we can't, but we want to add it to our stack because later on we might apply discount to it. Then when we get to 4, we check our stack and see if 4 is less than or equal to the last item in our stack. Now in this case it is. 4 is less than 8, therefore we can update 8 and apply this discount. Now you might be asking yourself, well, how do we know where we're going to be applying this discount? The indexes might range or might be different. Well, instead of actually adding the value or the price to our stack, we're actually adding the index of that price. So instead of adding 8, we're going to add the index of 8, which is 0. Therefore, instead of checking if 4 is less than the last item in our stack, what we want to do is check if 4 is less than or equal to prices at index last value in our stack. Now I'm just going to do -1. That's a nice little way of getting the last element in a stack in Python. So we want to do this indexing to see if 4 is less than, this is going to evaluate to 4 is less than prices at 0, and that's going to also evaluate to just 4 is less than or equal to 8, and this is true. If this is the case, then what we can do is, I have to go back pretty far. Okay, if this is the case, then we can pop the 0 from our stack, because we have already applied a discount at this index, and we would never have to do it again. Because remember, as soon as we see an element that's less than 8, we can apply the discount and we don't have to do it later on, because we want the minimum j value. So we can pop the 0 and then say at index 0 in this prices array, change it, update its value from 8, its current value, minus the current price we're looking at. So 8 minus 4 is 4. Now 2, we might apply, 4, we might apply a discount to 4 later on. So we want to add that to our stack. Remember, we're doing indices, therefore I added 1. Now when we get to 6, we want to do the exact same check, see if 6 is less than or equal to the index, the element at index 1, which is the last element in our stack. In this case, it is not, because the element at index 1 will be 4, and this is incorrect. So we cannot apply a discount of 6 to 4 because 6 is greater than 4, but we will still want to add 6 to our stack, and since it has an index of 2, we add 2. Now when we're looking at 4, we see that 2, yeah, wow, I said 4, sorry, I meant 2. Now when we're looking at 2, we see that 2 is less than or equal to 6. So we can apply a discount of 2 to 6. Now where am I getting this 6 from? Well, it's the element at index 2, which is the last element in our stack. But we want to do this check repeatedly. We want to do it while this right here is true. While 2 is less than or equal to prices of stack. There. So while this expression evaluates true, we want to be updating that value. So the first one is be 2. So 6, I index 2 is 6, and then 6 minus 2 is 4. So now that 2 is out of the stack, and we're still left with this 1. Now, index 1 is a 4, and 2 is also less than 4. So we can apply this kind of 2 to 4 as well. That would give us 2, because 4 minus 2 is 2. Then we can also remove the 1 from our stack. Of course, we need to remember to add the current, the index of the current price we're looking at, which is 3. So now once we get to 3, we check is 3 less than or equal to the index, the element at index 3, which is 2. That is not the case. Therefore, we do not pop it. We do not apply any discount at all, and we just leave it as is. And we add the index of 3, which is 4. And we're done. We have completely gone through this whole array, and we only apply discounts to index 0, 1, and 2. Every other index goes untouched, so their price does not change. And our answer will be 42423. And as you guys can see, that is the correct answer. So that was the very important trick, or the key thing you guys have to take away from this problem, is that every element could be used as a discount for the elements before it, and a discount could be applied to it later on. So now that we discussed it, let's actually implement it. So let's call our stack with an empty as an empty list. And now let's iterate over the prices list. The current price is going to be the price at this index. And now we want to take care, or we want to check if we can use this current price and use it as a discount for previous prices. And so since we want to do that repeatedly, we want to use a while loop. We want to do this while our stack is not empty and the current price is less than or equal to the price at index at the last index in our stack. So while this is true, while this whole expression right here evaluates to true, we want to get the index in our stack. So see what's the price we can apply this discount to. And at that index, let's actually apply the discount by subtracting the current price we're looking at from it. And of course, we cannot forget to add to our stack the current index we're on. And this is all we really need to solve this question. So let's use some example cases. We see that all of these succeed. Now let's submit. And it's accepted. So this was a pretty good problem. It really had to force you guys to look at it as a stack. and to see the importance of each and every single element. And now you might be wondering, well, what is the time complexity of the solution? Well, the time complexity is actually O of n. And if you get a little bit confused about that because there's a while loop inside this for loop, realize that this while loop is not going to run n times every single iteration. This while loop will only run n times, in total n times. So instead of being n squared, it's more of big O 2n. And as you know, this evaluates to big O of n because we drop coefficients. And there you go. And of course, memory is also O of n because in the worst case, our stack can have n items or n minus 1 items. So hopefully you guys fully understand this problem now. If you guys are interested in what we're doing with this event, then make sure to join the Discord as I showed in the beginning. But other than that, I hope you guys enjoyed and I hope this helped. Thank you.